2.5 million light-years away in the Andromeda galaxy. A star the mass of 13 suns just vanished. No explosion, no flash. It simply wasn't there anymore. And for the first time, we have a picture of what replaced it. You're listening to Stardrift FM. I'm your host, and tonight, March 7th, 2026. Tonight, a star that collapsed silently into a black hole, Japan's private rocket fails for the third time in a row, while its government cargo ship quietly has the best week of its career. A comet heading for the sun that might be visible in broad daylight come April. A new way to measure the expansion of the universe using background noise from black hole mergers. China's reusable rocket is almost ready to fly, and scientists who can now warn us about dangerous solar storms a full year in advance. Grab your coffee, settle in. Let's go. Okay, so somewhere in Andromeda, the nearest big galaxy to us, there was a red supergiant star, about 13 times the mass of our sun. In 2014, it started getting a little brighter in infrared. Then it faded, and then it essentially disappeared, fading to just 7% of its former brightness. What happened? Well, a team led by Kishal AD at Columbia University has been watching this spot with JWST and the Chandra X-ray Observatory. Here's what they found. The star collapsed, but its shockwave was too weak to trigger a supernova. The outer layers fell back, the whole thing just imploded. A newborn black hole wrapped in a thick blanket of dust. JWST found a faint, extremely red object at those coordinates, the dusty cocoon still glowing. Chandra looked for X-rays. Nothing. That's actually the key detail. An active, accreting black hole should be emitting X-rays. The dust blocks them completely. The team's prediction, in about 27 years, the X-rays will finally pierce through. So we're looking at baby photos of a black hole. The most complete observational record of a star becoming one. There is a competing theory. A second team suggests it could have been two stars colliding instead. That debate is unresolved. Either way, something extraordinary happened in Andromeda, and we watched it. 7%. A star faded to 7% of its original brightness, then stopped being a star entirely. Japan's private company Space One launched its Kairos rocket for the third time on March 5th. 69 seconds into the flight, the autonomous safety system shut it down. The rocket was terminated over the Pacific at 29 kilometers altitude. Quick recap. Flight 1, March 2024, 5 seconds. Flight 2, December 2024, about 3 minutes. The rocket started tumbling. Flight 3, 69 seconds. Each one technically a longer run, but none of them have made orbit. Space One is claiming the autonomous safety system may have malfunctioned, that the rocket itself was performing fine. Whether that's true or not, the result is the same. Japan has 0 successful commercial orbital launches from a private company. There are other Japanese commercial launch companies. Interstellar Technologies up in Hokkaido has done several successful suborbital flights. But orbital is a different beast. Meanwhile, SpaceX, Rocket Lab, and Chinese commercial launchers are doing this routinely. Space One has raised about $130 million. They'll probably try again. But this is getting difficult to explain. Now here's the contrast. Same week, same country. JAXA's brand new HTV-X1 cargo spacecraft is departing the ISS right now. And it's not just leaving, it's going solo for the next 3 months. HTV-X1 is the first of Japan's next-generation cargo craft. It delivered 12,000 pounds of supplies to the station. And unlike the old Kunatori ships, which would deorbit immediately after departure, HTV-X1 is staying in orbit to conduct its own experiments. It carries a small satellite deployer, antenna tests, solar cell demonstrations. It basically becomes a free-flying space station for a while. Then, around June, controlled deorbit. Japan's government space program is having an excellent week. Japan's private space program, less so. Two very different stories from the same country. There is a comet heading for the sun right now, and it's the most interesting one in years. CEAS 2026 A1 Nicknamed MAPS after the four astronomers who found it in January from the Atacama Desert in Chile, is a Kreutz Sungrazer. That means it's going to pass extraordinarily close to the Sun. On April 4th, it will be just 160,000 kilometers from the Sun's surface. For reference, our Moon is 384,000 kilometers from Earth. The question, does it survive? Kreutz Sungrazers are fragments of an ancient comet that broke apart centuries ago. Most of them are tiny and disintegrate. But MAPS has a nucleus that could be up to 2.4 kilometers wide. That's large for one of these. The comparable comet, Lovejoy, survived a similar pass in 2011 and became briefly naked-eye visible in the southern hemisphere. If MAPS survives, and that's a genuine if, the brightness predictions go from impressive to slightly absurd. Some models suggest magnitude -16. That would make it visible in broad daylight. Most realistic scenario, something like Lovejoy, still spectacular. April 4th, mark the date, we'll know by then. Alright, this one's for the physics lovers. The Hubble constant, how fast the universe is expanding, has a problem. Two different measurement methods give two different answers. Local measurements, using supernovae and Cepheid stars, say about 73 kilometers per second per megaparsec. The Planck satellite measuring the CMB, the leftover glow from the early universe, says 67. That's an 8% gap that has not gone away in years. A team at the University of Illinois and the University of Chicago just proposed a third method. The gravitational wave background. Here's the idea. Every black hole merger that ever happened across all of cosmic time produced gravitational waves. Most of those mergers are too distant or too faint to detect individually. But together, they create a faint, persistent hum. The key insight, how loud that hum is, depends on how fast the universe expanded. Faster expansion means the volume is spread out. Mergers are spread out, quieter hum. Slower expansion means mergers pack tighter, louder hum. So if you can measure the hum, or even its absence above a certain threshold, you can calculate the expansion rate. The team used the current non-detection of the background to rule out certain slow expansion scenarios. In about 6 years, as detector sensitivity improves, they expect to actually detect it, which could finally settle the argument. A third, completely independent measurement method. From the silence of merging black holes. Cosmology is wild. Late March 2026. That's the current target for the first flight of Kinetica 2. A new Chinese rocket from CAS Space, the commercial arm of the Chinese Academy of Sciences. 52 meters tall, 625 tons at liftoff, 20 tons to low Earth orbit. Grid fins, landing legs, you know the look. Its first payload is Qingzhou-1 Lightship, a prototype cargo spacecraft for the Tiangong space station. 5 tons, total mass, about 2 tons of cargo capacity going up, and crucially, it can bring cargo back down. This is interesting because China currently relies on Tianzhou cargo ships. 13-ton vehicles that can't return cargo. Qingzhou is smaller, presumably cheaper per flight, and has two-way capability. The comparison to SpaceX Dragon approach is obvious. This is the maiden flight, meaning there's a real chance it doesn't work. But China's commercial launch sector has been growing fast. If it does, Tiangong gets another logistics option. Last one. Scientists have developed a method to predict the most dangerous solar storms up to a year in advance. Right now, the standard warning system gives us about 30 minutes. Between detecting a storm at the L1 Lagrange point, 1,000,000 miles from Earth, and it hitting us, that's enough time to, not much, warn people, hope for the best. The new method works differently. Instead of watching for an imminent storm, it identifies extended risk windows, periods of months or more, based on 50 years of X-ray data from previous solar cycles. It can tell you which specific regions of the sun, at which point in the cycle, are where the danger will come from. The validation is striking. The team submitted their paper between October and December of last year. After submission, Solar Orbiter detected massive superflares on the sun's far side. regions they had predicted would be active. They had no knowledge of those storms when writing the paper. That's a genuine, blind validation. And here's the timely part. Their model says we are currently in the first major danger window of solar cycle 25, right now through mid-2026. Southern hemisphere of the sun, 5 to 25 degrees south latitude. 6X class flares fired off in the first 4 days of February. We've been warned. Practical upside: Artemis crews, ISS astronauts, satellite operators, airlines on polar routes. They all benefit enormously from a year's warning instead of 30 minutes. This is real infrastructure for living in space. That's tonight's Stardrift FM. A star quietly became a black hole in Andromeda, and we watched. Japan had the best week and the worst week in its space program simultaneously. A comet is about to try to survive the sun in April. The universe's expansion rate might be solved by the hum of ancient black hole mergers. China is about to try its new reusable rocket. And scientists are tracking dangerous solar storms a full year before they arrive. This is Stardrift FM. Thanks for tuning in. Subscribe for new episodes every week, and I'll see you next time.